Okay, this is number 6 in the domain worksheet. I actually looked at my answer key that I put up there and it was wrong. So this is the correct number 6 from that worksheet. Okay, so we're looking for domain, which means in our case right now that you can't have a 0 on the bottom of a fraction and you can't have a negative under the square root. So those are the only things we're looking at with domain right now. Everything else is all real numbers. So domain is asking what x can be. Right now, the only time we can't have something for x is if it's going to make a 0 on the denominator or a negative under the square root. So, or a negative under an even root. So right now we have an even root right here, a square root, and a denominator. So we know that that can't be 0 and it can't be negative under the square root. So we're going to set that the square root of 20 minus x is greater than 0. So it can't be 0, it can't be negative. Square both sides, you get 20 minus x is greater than 0. Negative x is greater than negative 20, and so x is less than 20. Okay, so that's one part to our domain. Then the next part, we have these two binomials that are being multiplied together that are underneath the fraction, so they're in the bottom. They can't be 0, so x minus 5 cannot equal 0. So x cannot equal 5. And then x plus 7 cannot equal 0. So x cannot equal negative 7. So I just solved those like I would solve a regular just linear equation and set it equal to 0 and solved it. But it can't be 0, so it's everything but that. And then the last part we have right here, we have another square root. This one is not on the denominator, so it can be 0, it just can't be negative. So the square root of x plus 9 is greater than or equal to 0. Okay, so it can equal it. You can have the square root of 0, it's 0, but you can't have the square root of negative 1, for instance. So square both sides, you get x plus 9 is greater than or equal to 0. So x is greater than or equal to negative 9. So that's where I messed up on the answer key. I put positive 9, not negative 9. Okay, so now we're going to draw a number line, put all of our numbers on there. These are all, these four right here are our key points, right here and here and here and here. So that's where changes are going to happen on our number line. So first we have a negative 9, then we have a negative 7, and then we have a positive 5, and then we have a positive 20. Okay, so right now we're saying that x can be everything. But let's start with a negative 9. X has to be greater than or equal to negative 9. Okay, so I'll color in, filled in circle on the negative 9, and it's going to shade to the right. So everything over here is going to be shaded for that guy. Okay, it's going forever. That'll make that one true. But x cannot equal negative 7. So I'm going to make this in red. X cannot equal negative 7. That is a hole in your graph. It can't be there. Also, x cannot equal 5. So you have another hole in your graph right there. It can't be 5. And x has to be less than 20. Not equal to, but less than 20. So it needs to go this way, not including those holes, all the way to 9. Okay, so that's the graph of the answer. All the red part is the answer, I guess. So red, anywhere where it overlaps everything else. So everything is overlapping like that. Okay, so now if you wanted to put it in interval notation, you go left to right. So starting at the far left, we have negative 9. It's included, so it goes in a bracket. And then you want to go to the first stop, which is negative 7. Okay, not included. It's a hole in your graph, so it's not included. Then we want to start back up. So we're going to start back at negative 7, but not include it. And then go all the way to 5. Don't include that one either because it's not equal to. It's an inequality. These holes mean parentheses, not brackets. They're not included in your graph. This one, the negative 9, is filled in, so that's a bracket. So parentheses, parentheses, parentheses on those. Okay, so from 5, we have to start back up. So in union with 5, all the way to 20, not included, and now we're done because we've stopped overlapping. The red part is overlapping, the purple part is not. So now we're finished overlapping. So this would be your answer for the domain and interval notation.